Okay, in this video, we are continuing assignment number 5 from my Calc CD class. I think this is probably part 3. We're only doing problem number 35 though. So it's the integral from 1 to 2, the integral from 1 to 3 of natural log of xy all over y dy dx. So the first thing we got to do is integrate this thing with respect to y. So what I'm going to do is I'm going to actually do a u substitution. I'm going to say that u is equal to the natural log of xy. The reason I'm doing this is that I had a really hard time doing this in my head. So then du is going to be 1 over xy times, we're finding the derivative with respect to y, so the derivative of xy with respect to y is x, so we get x, and then dy, because we're doing this with respect to y. So this simplifies to du is 1 over y dy. Okay, so if we do all the substitutions, we actually just end up with the integral of the natural log of xy is u, and then 1 over y dy is du. So that's what we have. So this part is just going to give us 1/2 and then u squared, and then plus c, but it's a definite integral. So since u is natural log of xy, we're really going to end up with 1/2 the quantity natural log of xy squared from y equals 1 to y equals 3, and then dx. Okay, so we plug in 3 and we plug in 1. So we'll get, plug in 3, we get this, and then plug in 1, we get this. All right, so this is where we stand now. Now we have to integrate the natural log of x squared, or the natural log of u squared. It'd be nice to have a formula for the natural log of u squared, the antiderivative. So I'm going to do that. So we're looking at this. I don't know what that star is doing there. All right, so I'm going to do integration by parts. So u is the natural log of x, and then dv is also the natural log of x, but dx. Okay, so you have to be really careful when you do this. Du is going to be 1 over x dx. V is going to be x ln of x minus x, because we have that memorized. Otherwise, you have to use integration by parts on that as well. So we're going to get our overall integral. Let's just call this I. So I is going to be uv, which is this, and then minus the integral of v du, which when you multiply v and du, you end up with natural log of x minus 1, right? Because you're dividing everything by x. All right, and then dx. Now we have to integrate that, but that fortunately is not a bad integral, I think. So the part that we start with, then minus the integral of natural log is x ln of x minus x. The integral of x is just, no, the integral of 1 rather is x. So this is where we stand. Then distribute the negative, collect like terms. We end up at this. So the integral of natural log of x squared dx is going to be x ln of x squared. Sorry. I'm listening to the end of the Kardashian era as I work on these problems. I accidentally hit play on that. Let me make sure that doesn't happen again. All right. I don't even know if you could hear that, but if you could hear it, that's what I was listening to from what is this? Cruel World Happy Mind is the YouTube channel. And that's a little insight into what I listen to sometimes. All right. So we're going to take this as our formula and we're going to carry it over. So we're really looking at this situation. We now have a formula for integrating this thing. So let's employ it. So you could basically change all the x's into u's in that, and it'll just give us, this is how you do it. So I'm going to get 1/2 for sure. Because that u is equal to 3x, there should be a 1/3. So we're going to have a 1/3 by the chain rule, and then you get 3x, natural log of quantity 3x squared minus 2 times 3x. Natural log of x plus 2 times, natural log of 3x plus 2 times 3x. Whew. Okay, that's when you just integrate the natural log of 3x squared. Natural log of 3x squared. Now we also have to do minus the integral of natural log of x squared, which is just that formula. So minus just the formula that we came up with. We're going to evaluate this, or try to, from 1 to 2. So there's like a lot of work you can do here. First of all, if you look at this thing, we got this 1/3, but then there's a 3 in everything that it's being distributed to. So I'm just going to cancel those out, which is a really good move. Then also there's an x in everything. So I'm going to factor the x out because I think it makes it look a little easier. So we'll have x, and then we have natural log of 3x squared minus just 2 natural log of 3x, and then just plus 2 because we factored the x out, right? So if we distribute the x again, we get back to what we had. And then minus this thing. So I'm going to distribute the negative, I guess. I don't know. I'm trying to get rid of parentheses, although I could have just like left the x in for the last part. I just think this makes it a lot easier to deal with at this point. Okay, so there's one other thing that you might notice. You have that like plus 2 that's just kind of hanging out there, but it's also times x. So you have this, and then at the end you have minus 2x. So those are gone also. So I'm going to cancel those out. And finally we get to this. Now I'm going to try to evaluate. And when I say try, I mean try. So we have 1/2. We're going to plug in 2 for x. I'm also going to distribute as I do this. So I get 2 natural log of 6 squared, then minus 4 because it's 2 times negative 2. And then you get minus 2 natural log of 2. I got lost. So when I was plugging, that's all from just plugging in 2. Yeah. Okay, so that last 2 natural log of 2 squared confused me, but I don't have to distribute the x to that. I probably could have done a better job like color coding this. I mean, I'm finding it confusing. So then it'll be minus, we have to plug in 1. Fortunately, the natural log of 1 is 0, so a lot of this zeroes out. So it'll be minus, you'll get the natural log of 3 squared, and then you'll have minus negative, which is plus 2 natural log of 3, natural log of 1 is 0, natural log of 1 is 0. And that's like basically it. I don't think there's any more simplification that I would ever want to do with it. So that's going to be my answer to this. That's number 35. So I hope this was helpful and good luck.